Welcome back. Sorry for my absence, but, I have a life. In other words, I went on a business trip and got the flu. Yeah, fun times. But anyway, it's time we continue with this series on Make Electronics, where I go over all the experiments in this book and its successor, Make More Electronics. So, we are now on experiment number 8. A relay oscillator. Like always, we're going to need some stuff. Now, the book goes into making your own hookup wires, and so here's some just solid core wire that I like to use. It's cheap. Well, it is cheap for now. We'll see how that changes. But anyway, here's the hookup wire, and obviously you'll need some tools. Wire stripper, cutter, so on and so forth. But I think that's pretty straightforward. But the book does go to mention that you'll need your handy 9-volt battery. This series would not be possible without the trusty 9-volt battery. You're going to need your battery connector, your breadboard, your 9-volt relay, some red LEDs, some clicky switches, assorted resistors, capacitors, etc. Okay, so the book goes into making jumpers and everything like that. I have confidence that you guys are able to read and figure out how to make a wire, if you want to. I am still using the pre-cut ones that you can just get, because they just work, even that they're kind of annoying. Is what it is. If you're doing something permanent, definitely make your own wires, which we will get to in a moment, and I will show you something special. One of the other reasons why this took so long to do, or get out. Okay, so as you can see on page 69, the book shows a few different examples of things that we're going to work with in this experiment and going forward. So let me zoom in. Okay, so I know we've already really kind of gone over a lot of this stuff before, but I'll show it again. So this is your slide switch. And these are your tactile switches. I call them clicky switches. Okay, so this is an example of a trim potentiometer. You can turn it and change its potential. Okay, if you don't know what an electrolytic capacitor looks like at this point, I don't know what videos you've been watching. Obviously not mine. So there's a small one. That's 100 UF. So, and this is a ceramic one. So, come on, camera. There you go. Small. So the ceramic ones usually get into when you're going into very low values. So, okay, so the book also mentions, okay, so this is a diode, one version of a diode, and there's another version. Can you see that? Come on, camera. It's probably too small. There it goes. Tiny. These are known for their little orangish glass look that they got going on. Okay, transistor, which I don't think we've used any so far, but this is the basis for basically modern society and can be argued as the most important invention in human history. The transistor. This is what replaced vacuum tubes. And here's just an old example integrated circuit, which basically all the things that we may have made over the time, and we'll make in the book, a miniaturized version that is in a nice, clean, nice package. Very neat. Okay, so I'm going to put all this to the side because we frankly don't need it. That was just for your convenience. So, going in the book, we're going through a series of relay circuits. So the side, you can see going through and basically building up how the circuit works and different different stages of how it goes, where the basic circuit, when power is applied, and then rewiring it a little bit. So what I have done is, for this one, correlates to figure 813. So I'm going to hook my power up. Okay. That figure 812 is not working. What did I do? So normally I would probably do this off camera, but I figured it might be good to show you guys. So nothing's working. That's because I originally had something over here, which I will show you the better version here in a minute. But I'm missing some feeds to negative. So we're missing that one, and we're also missing this one. There you go. My wires are a little long, but there you get the point. Okay, so we press the button. There you go. If you're paying attention, you can hear the relay clicking. Very straightforward. Now watch what happens on this one. Now, the only addition to this one, which correlates to figure 814, is we've added a 1000 UF capacitor. 1000 and 100 seems to be the most popular ones. But there are a ton of different kinds. So watch what happens. There's a bit of a delay due to this capacitor being added into the circuit. So this is charged up. When you press that, it's holding the relay open just for a micro, half a second or something. And that's why it's not as clicky. And if I click it further, you get, some odd behavior. So that's pretty cool. Now, if you change the capacitor, you'll get different variations on time. So bigger capacitor, longer time. Unlike this one where there's no capacitor. So you're changing circuits. The second you click it over here, it stays open for a moment. That is pretty cool. Now, this is kind of basic, but I think you can see that how much this kind of thing can be used in your designs. Okay, now, like I said, I have a special presentation for you. Now, figure 815, here, I'll show you this one, is going to be demonstrating the charge and discharge of a capacitor. Now, given the current, let's see, how do I say this diplomatically without enraging anyone? Not that I really care. The stupid fucking tariffs caused me to change my long-term vision on what I wanted to do, and I pulled up plans to start making PCBs from scratch. As you can see, here's a copper plate. Got some stuff on it still. So I lost track of how many times I worked on this, because this is frankly a lot more difficult than it's advertised to be. But it's actually pretty doable at home. You just got to get the hang of it. So this is same copper, but it's got some photo reactive film on top. Basically the same stuff, I'm basically developing a PCB very similar to maybe how you would do a old-fashioned photo. So since I'm at home, I'm not going to get in, I'm just saying, I'm not going to get into too many details on this. I'm going to come up with another video on this. But since I'm at home, I'm doing the least toxic way possible. Because trust me, you don't want a PCB plant in your backyard. So, and I just wanted to show you guys, don't give up. This took a while to get the hang of. So this was the first real successful one. I had blown up the image to put on here, and the spacing was too wide for certain components, so I ended up having to redo it. And here it is. This is figure 815. As you can see, Make Electronics figure 815. So, let me see, it's not perfect. I'm still learning a lot of things to get better things, but every time I tried, it got a little better. So, I probably should have filmed this before I put the epoxy on, but, well, I wasn't thinking. So, yeah, this is UV epoxy just to cover up the traces. Let's see here. To cover up all the traces. And then flip it over, and there's your circuit board. This is figure 815. So, I'm going to plug it up to our power. And watch. Oh, it charges. And if I don't do anything, it will slowly discharge. Now, if I press it again, and I want to discharge it, I can press that. Charge. Discharge. Charge. And the longer I hold it, it will charge up to its max. This is a 1000 UF capacitor. So, there you go. And then you press that, and it just charges everything to negative. So that was, this took me a good month to figure out how to do. Yes, and I basically was going to do this plan for next year, but between tariffs and everything, I went and calculated how much my JLC PCB collaboration I did at the end of last year would have cost me. Yeah, like $200 in just tariffs. So, yeah, I'm not doing that. So yeah, figured out how to do it at home. So yeah, that's pretty cool. This was actually pretty fun to do. A little frustrating, but there'll be a new video. I'll have another video coming out eventually that will go over this process. But yeah, pretty cool. Now, as you know, the book goes into more things. It goes into basic capacitors, your farads, and what those UFs mean. UF is a microfarad, and so on and so forth. And how, reading electrolytic, reading ceramic capacitors, and stuff like that. I am confident you can figure that stuff out. Now, if you guys really want a dry video on this kind of stuff, let me know. I'm happy to do it. I think it's kind of dry. And there's plenty of other great people out there that have made videos on this stuff before, so no need to reinvent the wheel. So, that's it for this one. If you have any questions, let me know. Otherwise, stay sleepy, my friends.